Hello and welcome back to the Google APIs for Rust and YouTube Uploader development stream. It's Byron speaking, and don't be fooled by this issue. I conserve it. I will not reload it or do anything because it's just cached. GitHub is down. Just to tell you, GitHub is down. The first time I've actually experienced this, and it's terrible. And it actually hinders me to upload that packet 2000. So I will try to implement something already and see how far I go or get, and I will reload from time to time just to be sure I'm the first to realize when the GitHub is back up, because crates depends on GitHub. The crates index does. Did you know? I didn't realize it until now, actually. I didn't ever read what Cargo told me, apparently. All right, so we are back with the JSON tools, and I need a lexer. I need something that's able to just get a stream of characters and parse it into lexical tokens that can then more easily be understood by parsers, filters, and so on. And that's how that's going to be. It should be relatively easy to implement. I don't expect lots of problems there. But first of all, I would like to have a test case. And as we will have some test data built into it, I think I will go for having an integration test. And to get an integration test, I guess we will have a new file here and a new folder. Let's make a new folder. Source. No, wait, it comes here to the top level, right? Tests. And in here, you dump whatever you want to dump, lexer. And I guess here is where you, actually I don't do this very often. I'm not sure if every file, every function in here is going to be its own foobar snoo. Let's see what happens now if I run, oh no, not here. Cargo test. Oh cool, it's already running foobar snoo. And I think all I have to do is, the question is, do I have to do the extern crate stuff? Let's try. Extern, do I have to do it here? json-tools as JT? Or do I have to do it on a file level? No, I have to. Okay, each function here is put into its own binary. So that's what integration tests are there for. I get it now. So how does it look like then? Target, debug. libjson-tools lexer. Okay, no, it's one file. Does it also mean I can put it here and then say JT it works? Oops. Use JT. Yeah, I get it. Oops. Use. No, wait. This should work, huh? Oh, it's not pub. That's why it didn't work. Okay, so that doesn't work. So you have to put it here, I guess. This should definitely work now. Interesting. It can do it. Yeah, call me stupid. I don't do this a lot. Do I have to? I don't have to import it. Do I have to explicitly use it? Even though I have the crate thing already? Unresolved import JS. There is no JS in. That's true. And it's not a module that I get. It's like use std, but yeah. Maybe this works. Oh, what? Oh, JT. Did I write JS all the time? Did I do that? I think I did it. No. Amazing. Use JT, it works. And now it should be top level and I should have it, huh? I'm not sure about this at all. Why is it so difficult? Why am I so dumb? There's no it works in JT. But I thought it was. Oh, it's a test. What the heck? Oh man. See, there we go. And this actually works. So we can say JT, it works. And the cause of my problem was just that I did it the wrong way. Okay, cool. So yeah, what I would like to do is provide a reader to the thing that allows to read a stream of bytes, or maybe an iterator, a character iterator, huh? Isn't that the interface you would want to have? Which is kind of, I think I've seen this in CERT even, and I found it a bit astonishing because that means that each character gets, for a moment, basically wrapped into an optional, which makes it far bigger than it actually is, I think. And it's kind of some overhead associated with that. But maybe it's not under the hood. Maybe, I mean, it's idiomatic, that's for sure. But yeah, I'm just saying. Simple lexing. Yeah, let's do this. Are you back? Nope, you're not back. Maybe you are back and nobody knows. Hopefully there can't be a new crate. Everything is down. GitHub is totally down. Jesus Christ. That's terrible. For everyone, they've got clients who pay. They will hate life now. Yeah, so let's get some JSON stuff going. Yeah, anyway, what's the standard way of doing it? Should I have a stream reader and just read characters, read buffers, and then parse as long as I can? Should I be stream-based or iterator-based? Let's have a look at the interfaces that I can use here. I think Rust, char. Yeah, well, I could just say I want an iterator that works on chars. And this is easy because usually I have strings, and I think this is something I could live with. Yeah, and you could easily wrap reader to produce characters, basically, or to get that, or to chain that together, maybe. But I do wonder what a good way would be to do that. Let's see, read. We could read to string. We can read supports that already. Yeah, so that's what I want, right? I get a char iterator. Cool. So let's define that. Let's define what. Who gets the char iterator? Huh. So I guess the lexer, the simple JSON lexer. I call it JSON lexer because right now it's just simple because I say so, not because by definition it has to be simple. So let's just do that then. So it's a struct JSON lexer. It has a built-in stream chars, which is an iterator. And I don't think last time I tried it wasn't yet supported to specify what I should be. This is then just specified in the implementation. But maybe I will just try. Maybe this works then. Oops. where I is an iterator with an item being a char, huh? Like that? Is that a char iterator? Let's see what he says. Let's see what he thinks about it. Oh yeah, cool, and I have linting. So that's warning, that code. That's fair enough. And it actually compiled. I mean, I'm pretty amazed by that. Pub. Is that how it looks like? That looks a bit funny. Let me do it like that. Okay, so that is this, but that's not public, so we need a new here at least. So impl json-lexer. Oh, we also want to implement iterator on him. That's important, which means we need a next function, because it's gonna be exactly that. It's gonna be iterating over the individual tokens, and the iterator protocol is what we want there. The iterator trait is what we want there. But we also want to be able to new it. And I guess pub fn new should do it there, where we, oh yeah, what is it? There's an I for json-lexer I, where I is an iterator with item being a character. So what do you say? Still says it's good. I don't trust it. But it's also cool that I can finally work with the advanced toolset of Sublime linter with Rust C support, which in my case I think uses cargo. Yeah, let's check the project settings, by the way. They're generic enough to actually work for me. Cool. Nice. So here we have new. Oh yeah, we want to return a json-lexer I. And now we have to return a json-lexer I with chars b chars, which also means we need chars of an I. There we go. Yeah, and I of course take ownership of that, because that's what we do. We take ownership. So here is our instantiation, and I'm just protecting myself, you know. I will not expose this, because that's going to be public API, and by default we take chars, and if you have other constructors at some point we'll have it, but I want to have the luxury of adding fields later without having to change or to break my API. That's the thing. And we are approaching 0.1, by the way. So yeah, I actually might want to set this later. No, I probably want to set this now. Like this, because that's already the 0.1 stream of stuff. So then if you want to implement, every time I'm here I have to check it. We finished emergency and are monitoring closely. This means we are back. They are fast. Cool. I can now do my cargo publish. But I don't want to do it on this one. No. Yeah, let's stash it away. Let's stash it away. What's stash there for? Stash. VIP. There it goes. And now publish. Give me my 20 seconds of fame. Do it, man. Do it. Do it. Oh my God. Oh my God. It's there. Ta-da! The bad thing is I've recorded on video that I'm a, you know, I don't know how to say it, kind of a bastard, just because I'm reserving the name before I have actual content. Even though I will definitely have content in an hour or so, I just thought, well, there's no rule that says you must have real content, so there you go. You know, I didn't break a rule. I just did what I had to do to win the game that only I was playing anyway. So what do you care? You know, it's good. And I have it on video. 2000. Celebrate. Yeah, somebody celebrate that. I do. Cool. We are back. We are back. Didn't take too long. Very good, very good. It's all back to nearly normal. Look, they're all back, but they went all down simultaneously. That's incredible. So that will be some analysis, and I will be looking forward to the blog post that they will definitely post about that. Cool. There we go. That's very nice. Yeah, so I can probably, I will keep going, but I have to clean up a little because I'm missing an issue that I work on, and because I couldn't create it and so on. I have to clean up the mess caused by 20 minutes of GitHub outage. Stash pop stash. There we go. And we are back to where we were. Cool. Okay, so now we can create a new guy, and I will do this right away, just because I can. Just want an example here, a very small example. See, so this is something we should probably be able to handle. Yeah, so let's call this. So is this allowed or not? However, if escape, those characters must be written using UTF-16 surrogate pairs. Okay, I can't parse this stuff. This is all, we have UTF-8 strings here. We do characters. Can be encoded UTF-8, UTF-16, and the default encoding being UTF-8. These encodings support full Unicode character set, everything. However, if escape, those characters must be written using UTF-16 surrogate pairs, whatever that is. For example, to include emoji character phase in JSON, or like that. Well, let's try it, huh? Why not? We have UTF-8 here. Unicode. Let's try that. So here's our test string. And we can do a fancy raw string. Bang, bang. Cool, it actually parses this correctly. Awesome. So let's use a raw string here, which makes it easier for us to embed these strings, and I love it. I just recently, actually yesterday, learned about that. And I guess what we can do is we have a string, we just say chars. And let mud it be a JSON JT JSON lexer. Can I just call it lexer because we are in the JSON world? I think I can. I can, and I will. Boom, there we have a lexer. Lexer new. And you shall have, oh yeah, this must live long enough. Does it live long enough? Does it? I will just find out. So again, here we go. No. Okay, now it's a valid string, right? And we go with chars. That looks funny, but it's totally valid. So does it work? Totally so. I like it. So this should be our first test. We should now be able to basically get all the kinds of lexical tokens that we would expect here. And I guess, how much time? 20. Okay, so what's the lexical tokens that I would expect? I think it's time to set them up. So pub enum token. And one is white space, because I want to be able to filter the stream without losing any kind of white space information. And the caller should just be able to get an index to that whenever it gets a lexical token. So all lexical tokens have a span that says from where to where in the original character stream we are counting basically. From where to where in the original character stream we have seen the items or seen the token, right? This allows us to basically reference it later and recreate that stream if we like afterwards. Yeah, let's do this. And I guess I probably want to have the source string. Let source be this. I probably want to have it here, just because I really want to compare these first 4 tokens in all their glorious detail before I trust it. I even then wouldn't trust the code entirely, but let's start to make it to, let's just set it up. And when we have reason to not trust it for real, we will have a even better test. So yeah, I think this will have a span as first argument for sure. They all might have a span. Can I encode this better so that this is always kind of having a span? Well, no. I could not use an enumeration for this. Yeah, I can have a struct for this, which is a token, and then token type, right? So that is a token type, which is white space. And then we just have simple types here. What do we have? We have white space, matches. What is there? Oh, there is different kinds of braces. Curly left, curly right. What's the kind of braces? Bracket left, bracket right. And we have, is there anything else that is allowed? Let's have a look. Yeah, I'm not parsing everything, right? I'm just parsing very simple stuff. I want to parse keys. I think I want to parse the colon as well. Null, for sure. Yeah, key, value, null, value. That's, I think, at least what I have to parse. And then a comma. Comma. Yeah. Colon. Ah, see? More tokens than I thought would be there. And the value thing, of course I could parse this here as Boolean true and false, and but this would just make it more complicated for me, so I say, well, I just parse values. So if it's not white space, it's by definition a value. Oh, wait. No, well, sorry, I will have to differentiate this. Otherwise, I can't know if this is a comma or just a non-white space value, right? So I could just say, damn it, I don't know commas. Do I have, for what I want to do, I just want to understand null. And I think the more I understand about the stream, the better, maybe? The lexer, yeah, the lexer is stupid. It just doesn't know shit. Yeah, so I guess Boolean true. I guess I want that. And what is this? This is an... must consist of only one object of an array type. Yeah, so that's even more. So we can't pass all the numbers then. I won't try that. Invalid, yeah. Invalid is the catch-all for something that we do not understand. And the question is when we find out that something is invalid. I have no idea. Maybe something is invalid if we don't know what it is, and something valid all of a sudden comes, like white space. Yeah, I guess that's what we want to do. It's going to be fun. I kind of like doing lectures. Kind of fun because they're actually usually straightforward if you get the hang of it. If you don't get the hang of it, then the mess starts. So I'm going to parse this stuff away. This is not a lexical token for me. I don't know about line breaks and stuff, but I guess I will just not do it. It's going to be a very simple JSON parser. Yeah, but we definitely have to understand whitespace in the sense of we have it as a lexical token, just because otherwise we would skip it if somebody tries to. Well, we wouldn't necessarily skip it if somebody tries to use it. Maybe not. Maybe whitespace is something I could indeed skip. But it's also something other people can do. Yeah, I have a whitespace token. Okay, pub enum token type. I think that's it for now. Oh, Boolean true, Boolean false, null value. That's a string value then. Let's be precise. Boolean true, Boolean false. Let me have a number, right? Yeah. Number. Yeah, that's it. All right, lots of tokens we have to parse here. I mean, it's not that bad, but it's going to be interesting. Probably a big match statement to start with. And then some logic that I hopefully get right. It's gonna be fun. And we always have to parse one token at a time. And we have to retain some state. We need to know our last span that we have seen, which might also be none. Obviously. Cool. But that kind of tells us more about the state that we are going to have. So, pub enum token, pub type. Oh. Well. Do I want to do an underscore type to just be able to use the term type? Kind. Let's call it kind. Exactly. This, error type usually is used, but in case of IO error, they call it error kind. And I guess that's a good way to differentiate this. So I call it kind as well. Pub kind shall be a token type, and pub. And now we have the span. Span shall be a span. And what is a span? Pub span. Pub struct span is nothing more than pub start end or something, huh? Start end, and yeah, we have to index a stream, and I guess then it's U64 what they have, just to be able to index everything independent of the platform. Yeah, U64. Pub start U64, pub end U64. And I guess what we can do is just keep our last token or something, because that will contain all the data that we might ever want, even though we will never be interested in the last kind. So I guess keeping the last span is enough for us, just because actually the cursor is enough. Cursor, which is U64 then, and this starts off at null, right? So the cursor is just the last count since the first call to new, and then we go next, 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 and this is how we set up our spans here. And that is it, I think. That is the data structures that we deal with. And we can say we want to call next on it, assert equal. So I'm just making up the first one, and then we have to implement it to the point where it actually does something, and if it's kind of fail a little more gracefully than what it will do now, because right now it won't even compile. Let's make it compile, and then we'll fail, and then we are done with that session because we have laid out our data structures. I think that's a good goal for this session. So assert equal, what do we have? It next is supposed to be sum, and then it's a token type. Let's just import all this stuff. Use, yeah, I can also do it like this, json-tools. Use json-tools lexer token span token type. We take everything. Good. So we have some token with kind being a token type bracket left. So how should I call it? End or start or last? Maybe last, huh? First and last, where last is one past the end. Yeah, that's something we should define here. I will add documentation to this before I finish this, I guess, because that's part of the deal. Enough time that we have to do that without feeling bad. Okay, then there's span with first and last. Span, which is a span first. I think it starts at 0. And last is 1, because there's definitely just one thing. And then we have white space from 1 to 2 and so on, right? So let's make it pretty. Idiomatic. I think that doesn't look too bad at all. Kind of like it. Yeah, so this is what I would expect here. That's our first token that we get. And to make this happen, we need to implement iterator next. Oh, it doesn't like something. Oh. Better. A bit better. Linter, show all errors. No linter errors. Cool, so that does compile. Awesome. Even though that should not compile, huh? But it apparently doesn't. It only builds, so you only see the build errors, not the errors resulting in the test cases, in the integration tests whatsoever. Cool. So here we have impl. I've never implemented an iterator. I think it's, no, I actually might have done that or might have seen it. I might have seen it. It's really simple. Impl iterator. Yeah, I don't know how to phrase it. Item is token type for can I just hard code this? Do I need to make this? Oh no, wait, this, no. This is supposed to, you know, these guys, they're anything, and you want to generically generate your lexers based on the actual iterator that you have. So this is what we want, just to get rid of additional, you know, against runtime method function dispatching. Yeah, we want monomorphism, we want templating here. Yeah, so that's fine. We don't get rid of that. For lexer, but this means we have to go for this stuff again, where this is that. Okay. So we implement this for all our lexers basically. Like this. And then we have a, oh, actually, I don't know. There was a Reddit post, Rust Reddit iterator. Nope. Was there recently? Telling you why iterators are cool and what you... Rust iterator Reddit. I managed to find it at some point. Beginner friendly. That's the one. And it had an implementation of that guy at some point, writing an iterator here. Input iterator 4, so that's how you do it. All right. Nearly. See, that looked a bit funny. Where item is token, is a token, obviously. Then we go on a mutable self, return none for now, and return an option token. Okay, cool. And this doesn't compile. Because we do not have an I here. Where I is this. So now it does compile. Cool. Now these guys are totally unused. That's why they're in yellow right now, but that's fine. Okay, so that would now cause a test failure here. No. Whoa. Debug. Okay. You want debug to be implemented. So I guess we can do it so that... there was one cool way to have config errors. So if there is a particular mode, like test, config test, and then the next item that we have this thing affect is derive. So debug will only be there if we are deriving. And this we have to put everywhere. And we're good. And this is how I can imagine this. Oh, something is wrong now. Officially wrong. Undeclared type name token. So token... Apparently this doesn't really apply anymore. Okay, there was this other article that I always find. Rust meta. What did I search recently? Was config Rust test, Rust config test, feature test. Was it this? The manifest format, it certainly is not. Maybe I found it here actually. Was it Hoverbear who did that blog post? No, maybe not. Maybe he did. Oh, damn it. I need this information a lot recently. Yeah, fuck it. Then I just derive debug from it right now and try to fix it later. Oh. There we go. Better now? Oh yeah, it's not comparable. Partial equality we want as well. That can be default implemented, fortunately. Okay, so now we should be able to just compare the entire structure and see it's not the right thing. But that was expected. Let's work on the docs. Right now we don't have a single doc string, so this will not work. But we will start. That's kind of, you know, it's redundant. All white space. The type of the token could not be identified. Should be removed if this lexer is ever to be feature complete. Because that's kind of our plan B. If we don't get it, we say, well, we didn't get it. And that's where our token type will start out at. So if for some reason our code isn't able to set it to something better, then it will be an invalid token type. So that's a single character, a null value, any JSON number, like or 1 to 3. False. True. Probably good for me to see as well what I meant with it. A JSON string like foo. I don't know what they do with multi-line JSON strings, but I just, you know, I will have to deal with escaped stuff though. But that's not so difficult at all, I think, but I will have to do it. Otherwise I can't parse strings correctly, and I will have to parse them after all correctly enough to be able to do it. So we should have a test that test string escaping and multi-lines line strings. Let's do string escaping first, and be sure we also do multi-line strings like so. That's important. So that's just this, and actually we can do it as markdown. We can do it like that. So let's embrace these in like so it will look real good. in the generated documentation. Yeah. Sometimes I forget the obvious. Weird. Good. Then key. Yeah, that's string value. It's like string value, but on the left side of the column. Okay, so that's, yeah, but on the left side of the column. Like a string value, but on the left side. Actually, from the Lexer perspective, we don't know that. There is no such thing as a key. So there's just a string value and a colon. Yeah. So that's just this. And that's just bracket, let's call it bracket open and bracket close, huh? And because it's a bracket, curly open is this. Curly closed. Yeah, curly close. Past or present? Must be open then, huh? Bracket opened. Don't like it. Let's do this. Oops. That's the close. So let's group them a little bit more. Here come the brackets, colon, and just the character thingies. Colon, comma, brackets, colon, comma. The values, number null, invalid. Okay, that's the guys. We have a span. Indicates a pair of indices into the character stream returned by our source iterator. Starting at null. Yeah, well, it is an exclusive range where first points to the, it's an exclusive range. Yeah. The first index of the index of the first character of the span. That's it. Of the index of the first character in this span. Well, it's clear. Index 1 past the last character in the span, which is again clear. It is an exclusive range. I think that's most of it, saying most of it, and this one past. Yeah. I think it's, in iterator terms, last is last, which is inclusive, and end is one past. One past last. End, see? So end is the kind of term we want to use here. So we use end. It's that easy. This still works, but this will now not work anymore. end. Good, so here we go. Token, a lexical token. Identifying its kind and span. The span allows to reference back into the source character stream to obtain the string making up the token. That's the whole point. Yeah. Probably I want to put this here, huh? The exact type of the token. Alrighty, there we go. Yeah, and I will have a benchmark for this just to see how many tokens we can do just for fun. Now that we're doing it. Okay, that's it. Well, it's kind of self-explanatory here. Returns a new lexer from a given character iterator. It will traverse all characters and convert them. Well, and well, that's not what it does here. This is what it does here, but that's kind of clear, right? Lex the underlying character stream to generate tokens. So let's see how that looks like. Should be relatively complete here. And for some reason, it still doesn't open the documentation. This used to work. But I shall just open it manually then. Open target doc json-tools index. Cool. Oh, Alexa has no documentation at all. Too far up, didn't see it. Alexa for ASCII JSON. For JSON, for ASCII. Yeah, actually, JSON encoded data is always ASCII. Well, it's not ASCII, but you know what I mean. For UTF-8 encoded JSON data. So let's do that again. Voila. And there we go. Token type is here. That's actually quite cool. I think that's useful. Yeah, I think that's useful. Also, you know, the simple literals here. So if it's like that, then we can kick this out as well. And considering this, I think that is sufficient as well. Good. Fine. Let's add this. Oops. And call it, what is it? what was our first commit? I think that was just show initial commit. So what do we have? We have a Lexer as feature, right? And this is, yeah, we are on our way. It's not yet a feature per se. What is it then? Improvement, maybe. But it's also not, yeah, I don't know. Just intermediate, basically. But I want to commit it anyway. It's a good step. Feed Lexer. Data structures. And basic tests. The tests still fail as the actual Lexer implementation is still to be done. So yeah, that is it. Good, so I will take some time to catch up with my issues here and see how GitHub is doing, and hope to see you when it's when we are going to the next route and implement the actual Lexer. Thanks for watching and have a good day.